Hello, my name is Matthew Wilson, and this is my circuit, big even. Step 0 is what? What is the purpose of this assignment? What are we doing? What's the end goal here? And the scope of this assignment is to create a circuit that will accept an unsigned binary output from any 10-digit keypad, and will be able to output a value that we nicknamed high, but only if it's in its required parameters. Those parameters being if the input is an even number larger than 3, and we will name this circuit big even. Step 1 is identifying our variables. Our input variables in this case are going to be x's 4 through 1, where x4 is our most significant bit, and those will be for the decimal values 0 through 9, and our output variable, which will be labeled as h or high, that was stated in the previous description. Step 2 was creating our truth table, as you can see here on the left. Now this represents 4-bit unsigned binaries for decimals 0 through 15, and it goes through 15 because it gives us a good sign on how to use our don't cares, which are labeled as our x's here, which will in turn make it easier to create our k map. And then here, step 3 is our k map. This is set up, as you can see here on our left. The ones in the table are represented as the ones in our truth table, or our true values. The zeros are just our blank spots. So if you looked at the truth table and saw the zeros, these would just be filled as blank. You can write them if you choose, but I just decided it'd be best to save time and leave them blank. And then our x's here, which are our don't care values. And then the purpose of this k-map is to help us create the most simplified equation, which leads us to step 4, which is creating the simplified equation. From the k-map, we were able to create one, and the final result here is x3 and x1 prime, or x4 and x1 primed. And to avoid confusion here, just a little note stating that the inputs are shown as x4 through 1 here, 4 being the most significant bit, 1 being the least significant bit. And that leads us to step 5, which is our design process. So here we are in a program called Logisim, which is frequently used here in our CSC120 class. And we'll begin creating our big even circuit. And we're going to start off by doing this by creating our 4 input variables. We will align them like so. We'll use this by using our selection tool here. On the top right, looks like a cursor. From there, we can label our inputs. We'll name this one x4. And a little trick that I like to use is use the select tool here to just quickly Control-C and Control-V. And then we're going to go ahead and do this 4 times for the 4 of our inputs. And we'll start off with 4 up there and go down to 1 from our most to least significant bit. If you'd like to change the values here of the text box, you can go back to the A up here, the text box, and then just click on your desired one and change the numbers as you please. Go back to our selection tool here. And if you look at the equation found here in our last slide, you will see that x2 is nowhere to be found in our equation, therefore making it not needed when creating our circuit. So going forward with that, we're going to have x3, which is going to be ANDed with x1 primed, excuse me. So what we're going to do here is create these. And to find our AND gate, they're going to be located up here along with the poke, select, text tools, and everything of that sort, input, outputs here. And we're just going to grab an AND gate here and connect the X3. And with the X1 here, it's going to be primed, which is going to be represented by our NOT gate, which you can find up here again. Go ahead and change the direction here, and the easiest way to change the direction is to use the keys, the arrow keys on your keyboard. You can do that in all different directions. If not, you're also able to just click over here where it says the direction, north, east, south, or west, and you can do that as well. And then you're going to have X4 and X1 prime again are going to be ANDed together. You can do a little branch off the side here if you want to keep this not wiring. Throw in a little AND gate there and connect these. You see in our equation here that both the equations are being ORed together. So what we can do is grab a OR gate from the top here and connect the outputs. Connect the outputs from both the AND gates here into our outputs, giving us, into the OR gate, giving us our output, which then we can use the tool again, and we're going to name that H. Go ahead and center it there. Okay, so here what we're going to do for simplicity reasons is I'm going to go ahead and remove this input value of X2 since it is not needed. And I'm just going to simply do this by using the select tool. I'm going to go ahead and click on my input there and just delete it there with the backspace, as well as the text as well. And now I will be using the poke tool, which looks like a hand up here, in order to be able to turn on each of these circuits, each of these input values and receive our given output values. And I'll be doing this for decimal numbers 0 through 9. So first is 0, 0, 0, as we can see, input is 0. Next we have 0, 0, 1, still shows a 0. 0, 0, 0 again for 2, and that's going to be a no. 0, 0, 1 again for 3, and that will also be no. 0, 1, 0 is going to give us our 4, which is going to be our first even number higher than a 3. So that the output will be true. We have 0, 1, 1. False. 0, 1, 0, which is going to give us our 6, which will also be true. 0, 1, 1 again, which will give us a no. Then we have 1, 0, 0, which will give us our 8, which will be true again. And finally our 9, which will be 1, 0, 1, and that will give us an output of 0. And that is it for the design process of Big Even. Thank you.